Okay, so today we're gonna start our next lesson. This is gonna be on completing the square. So if you guys take it back to before break, we had a couple lessons on solving quadratics. The first one we used the factoring method, and we had to make sure one side of our equation equaled 0, and then we could factor solve. We also used the square root property in the third lesson to solve. So completing the square, we're actually going to have to factor perfect square trinomials. Okay, so we're going to go kind of dipping back into factoring from that one lesson, perfect square trinomials, and we're going to use this to be able to solve the quadratics. So up here at the top, whoops, my screen turned again. Up here at the top, I just want to first review and practice factoring these trinomials. So these are all perfect squares, and if you guys recall, a perfect square trinomial will be in this form. Let me rewrite it. A squared plus 2ab, it's an A, plus b squared, or it could be in the form a squared minus 2ab plus b squared. Okay, so if you remember that form, that's what we're going to use. And now when I actually factor it, I'm just going to have a factored square, like a plus b squared or a minus b squared. So looking at these examples here, the first one on the top left, if I wanted to find a and b, I could take the square root of the first term, square root of the last term, which would give me x and 4. And now to double check that it actually is a perfect square trinomial, I can take 2 times a times b, so 2 times x times 4, gives me 8x, which is my middle term, okay? So that means that I can just factor it like so, x plus 4 squared. It's just a perfect square. We have a plus sign because the 8x is positive. So on the right side of the top of your screen, top of your page, take a square root of the first and last term. We have x, we have 9. Okay, 2 times x times 9 is 18x, perfect. Okay, we need negative in there. So I'm going to have x minus 9 squared. Same thing with the last two, square root of the first and the last. We have x, we have 1. 2 times x times 1 is 2x, which is the middle term. It's positive, so we have x plus 1 squared. And the fourth one there, we have x and we have 5. 2 times x times 5 is 10x. The middle term is negative, so I need to have minus in there. Hopefully that rings a bell. Okay, we're going to apply this to quadratics functions in order to solve them. So let's go ahead and look at number 1. Okay, number 1, what I'm going to do here is I'm going to look at the left side of this equation, and I need to determine if it's a perfect square trinomial. If it is, I'm going to factor it. Okay, so I look up here, I have x squared, I have 4. I'm going to take the square root of both of those, so I have x and I have 2. Okay, now if you take 2 times x times 2, what do you get? 4x. Okay, and notice it's a plus 4x, so that is a perfect square trinomial, which means I can factor the left side x plus 2 squared. Keep the right side the same. So I'm just going to factor one side. Now notice I didn't set it equal to 0. That's because I can actually solve this now by using my square root property. So if you guys recall, your square root property says if you have a square, you can take the square root of that and the square root of the other side of your equation to solve for under the square. So I'm going to square root both sides, giving me x plus 2 equals plus or minus 5. And now I'm going to have two cases because of that plus or minus. We're going to keep solving for x by subtraction. X equals negative 2 plus or minus 5. And if I split this up, I would have negative 2 plus 5 equals 3, or negative 2 minus 5 equals negative 7. So that means I have two possible solutions. Either x can equal, and I'm just putting my solution set, 3 or negative 7. So we're just going to factor one side. Because we have a perfect square, we can just take the square root and get those terms by itself. Let's look at one more example from this top part. We can go over to number 2. So number 2, same process. I'm going to look at the left side. I'm going to factor it. So square root of the first and the last term, that's my a squared and my b squared. That gives me x and it gives me 6. 2 times x times 6 gives us what? 12x, okay? But if we throw a negative in there, then we'll have negative 12x. Okay, so we can factor it like this. X minus 6 squared equals 81. Now to actually solve this, I need to square root both sides. Don't forget your plus or minus. X minus 6 equals plus or minus 9. And keep solving for x by just adding 6 to both sides. X equals 6 plus or minus 9. Okay, so because we have two cases here, yeah.
Why is it negative? Because if a negative plus a negative equals a positive, and there's...
It's because the 12 is negative. So if the middle term is negative, then it's negative.
The term, like that whole term is going to be negative? Like the whole like x minus 6 is always going to be negative?
Yeah,
Okay.
a negative on the inside. Yep. Okay, so because we have two cases here, we can have 6 plus 9 gives me 15, or 6 minus 9 gives me negative 3. So that's a good call out. How do we know if it's a perfect square? If I go back up to this, the very top of our page, we wrote this out. So it's a perfect square if it's in one of these two forms. Notice the only term that can be negative is the middle term. So the a squared and the b squared both have to be positive. The middle term can be negative. The sign of the middle term determines the sign of your factored form. Okay, so that's why we have x plus 4 or x minus 9. The middle sign is what determines that. But the last term is always positive. The first term is always positive. Okay, we're going to look at a couple examples now where we will actually have to do what we call complete the square. Yes? Do you have a pass?
Yeah.
Okay. We're going to do what we call complete the square. Basically, what this means is that I'm going to have a quadratic. It's going to be maybe look like a perfect square, but it's not one. And I'm going to add something or subtract something from either side to make it into a perfect square. So there's a couple of steps I have to do to get there. My first step says rewrite as x squared plus bx equals c. Okay, so basically what that means is I need to have my x's on one side of the equation and my constant on the other side. So in this case, my x's are x squared and 8x. My constant 7 needs to move over. So I'm going to subtract 7 from both sides. The reason I'm doing this is I want to have a little bit of space so that I can figure out what the perfect square trinomial would be for that x squared plus 8x. What can I add to both sides to make the left side a perfect square trinomial? Leaving the 7 aside. Okay, so step 2, it says take half of b, square it, and add it to both sides. Okay, what is my b in this little equation? It's just 8. Okay, so b equals 8. Now it says, take this letter B, it says half it, so that's 4, and then square it, so that's 16. And add that to both sides. So I'm adding 16 to both sides. Now I have x squared plus 8x plus 16 equals 9. Now notice what we created on the left side. The left side is now a perfect square trinomial, because that middle term determines what the last term is going to be. Now I'm going to follow the same steps I did above by factoring this. So we're going to square root the first and the last term. That gives me x and 4. 2 times x times 4 is 8x. Okay, that's true. We're going to add those two because the 8x is positive. Equals 9. Don't change the 9. And notice it did in fact factor as a perfect square. You don't need to necessarily double check that, because if you follow the trick for b, it will automatically be a perfect square. Now I want to solve underneath. So last step, square root both sides. Plus or minus up here, so I have x plus 4 equals plus or minus 3. Now to actually solve for x, I need to subtract 4 from both sides. So x equals negative 4 plus or minus 3. Write your answer in your solution set. X can't possibly equal two things, negative 1 or negative 7, which I got from negative 4 plus 3 and negative 4 minus 3. Any questions so far? Okay, we're going to do a little practice with this. So if we go down below on the next page, let's go to number 5. Yes? We can talk about that after notes. I'm good? Okay, so number 5. First up, I want to get my x's on the left and my c on the right. So my constant needs to be on the right. We're going to subtract 27 from both sides. Now I have x squared minus 12x equals negative 27. Second step, I want to complete the square. I want the left side to be a perfect square trinomial. In order to do that, I use my trick. b equals negative 12. So I can make it into a perfect square if I take half of b, negative 6, and square it, which gives me 36. So now I have x squared. Actually, sorry, forgot. I'm going to add 36 to both sides. So I have a perfect square trinomial on the left side. Now remember, if I add or subtract anything from both sides of my equation, it doesn't change the equation. It's still the same function. I'm finding an equivalent equation, so this means the same thing as the original problem. However, now I can factor it. It's in a factorable form. So I can take the square root of the first and last term. That gives me x and 6. Notice there's a negative with that negative 12x, so it's going to be x minus 6 squared equals 9. And my last step here, I want to square root both sides using the square root property. Don't forget your plus or minus. Now I have x minus 6 equals plus or minus 3. Add 6 to both sides. So x equals 6 plus or minus 3. And last but not least, write your solution as a set. 6 plus 3 is 9. 6 minus 3 is, 3. Okay, relatively simple procedure. Let's look at number 7 together, and then we'll move on to some irrational solutions. So number 7, again, first step. I want all of my x's to be on the left side. So this 18x needs to move over. We're going to subtract it. And that 71 needs to move to the right. So I'm going to subtract it from both sides. Now I have x squared minus 18x equals negative 80. So that's my step 1. Step 2, look at my b. What is b? Negative 18. I'm going to take half of it, and I'm going to square it, which gives me 81, positive 81. We're going to add 81 to both sides to complete the square. So I have x squared minus 18x plus 81 equals 1. And now I can factor the left side. Square root the first and the last term. You get x and 9. It's a minus 18x in the middle, so I have x minus 9 squared equals 1. Last step, square root both sides. Don't forget your plus or minus. X minus 9 equals plus or minus 1. And add 9 to both sides to solve for x. So I have x equals 9 plus or minus 1. Do not leave your answer like this. I do want you to write out both possible solutions because we can add 9 plus 1 gives us 10 and subtract 9 minus 1 gives us 8. Questions? Okay, sometimes your solutions will be irrational. That is, there's going to be irradical in the answer. So let's look at an example. Number 9.
For like,
Yeah.
So like, are you just gonna do like the highest like square for like 18, or will you just take half?
You take half and then square it.
Okay.
Yeah. Okay. Number 9. So first step, I want x's on the left, my numbers on the right. So we're gonna add 4. X squared minus 2x equals 4. Next step, take b. We're going to take half of it and square it. We get 1. Add that to both sides to complete your square. I want to reiterate, we're not changing the equation. It's the same equation. It's just written differently. Okay, now I'm going to factor the left side. X, 1, subtract because of the minus in the middle, equals 5. And then square root both sides. So I have x minus 1 equals plus or minus root 5. Can we take the square root of 5? No, 5 is prime. It can't be simplified any further. So I'm just going to leave that radical there, still add 1 to both sides. So now I'm going to have x equals 1 plus or minus root 5. If you leave your answer like this, I will be perfectly content. If you want to write it out in a solution set with 2 separate answers, that's fine too. But you cannot combine 1 and 5. You cannot combine numbers with radicals. Okay, the last example on this page, we'll look down at number 12. Okay, so number 12. Same thing. I want all of my x's to be on the left side, so subtract that 6x. My numbers need to be on the right, my constants, so add 2 to both sides. Now I have x squared minus 6x equals negative 1. Now complete the square. b equals negative 6. Take half of it and square it to give yourself 9. So if I add 9 to both sides, I'll have a perfect square trinomial on the left. I'm going to use that. I'm going to factor it. Square root, x, and 3. Notice the subtraction, so we're going to take x minus 3 squared equals 8. And my last step, square root both sides. Can I simplify square root of 8?
4? No.
I'll write it over here. Let's see. I have space. Okay, square root of 8. So I have, what are some factors of 8? 2 and 4. Can I take the square root of 4? So I'm going to take out a 2 from that and leave the other 2 underneath. So I have plus or minus 2 root 2. Is that radical simplified? And then when I add 3 to both sides, again, you can just write it as so. X equals 3 plus or minus 2 root 2. If you prefer to write it out separately, that's fine too, but I will accept this. Questions? Okay, flip it over. Now, all of the equations that we've looked at so far, all the quadratics, that first term, the x squared, had a coefficient of 1. You haven't even been able to see a coefficient. If you look at all of these problems, the x squared has no friend. It's just by itself. What happens when a does not equal 1? And there's, for example, a 4 in front of the x squared. What does it say to do?
You square root the 4 too.
Okay, so we could think that maybe we could square root the 4 too. And when we factored perfect squares, I believe we did that in class. But a much easier way to solve it, and the way that we're going to solve it, is just by dividing the whole thing by that coefficient. So when I look at this, I'm literally going to take both sides of this equation and divide it by 4. Okay, so when I divide a polynomial by a number, I have to divide every single term by that. So I take 4x squared over 4, 8x over 4, negative 5 over 4, 0 over 4. Notice we have a fraction. That's okay. We can have fractions. So next step, get all of my x's on the left, all of my constants on the right. My constant is just 5/4. So I'm going to add 5/4 to both sides. So I have x squared plus 2x equals 5/4. Now I want to complete the square. So I take b. b equals 2. We take half of it and we square it. We get 1. So I'm going to add 1 to both sides of my equation. X squared plus 2x plus 1 equals, now how do I add a fraction and a whole number? I have 5/4 plus 1. 1 is equivalent to what? 4 over 4. 9 over 4. Okay, so I have 9 over 4 on the right side. Okay, now I take the left side. I have to factor that. So square root the first and last term. We get x and 1. It's a perfect square. The right side, just keep it the same for now. And my last step, square root both sides. So I have x plus 1 equals 3 over 2. Square root of when you take the square root of a fraction, you can just square the top and the bottom. Okay, last step, subtract 1 from both sides, and I forgot my plus or minus. plus or minus 3 over 2. Add 1 to both sides, subtract 1 from both sides, sorry. That cancels out the 1 on the left, so now I have x equals -1 plus or minus 3 over 2. Okay, so this is the same thing as what? Let's separate this out for ourselves. -1 is equivalent to -2 over 2. So we can add one group, and our second possibility is that we're going to subtract. So we get 1/2 and -5 over 2. So when I write my solution, x equals 1/2 or -5 over 2. Kind of a long process.
Will there be a lot of those on our test?
I think we're probably gonna have like 2 questions on complete the square, so it won't be anything intense, but probably not a lot with fractions. Let's look at example 2. So again, what's my first step if I see a coefficient? I want to do what? Divide by 2, divide by 2. So we have x squared minus 4x plus 3 equals 0. Now I need to look at b. b equals I'm skipping a step. What do I need to do next? Minus 3. Now I look at b. b equals -4. Take half of it and square it. We get +4. Add 4 to both sides. So I have x squared minus 4x plus 4 equals 1. Perfect square trinomial on the left. Square root the first and the last term. Yes?
On the last one, why do we put 0 over 4 when 0 divided by 4 is 0?
Because I still have to divide the whole thing by 4. It doesn't change the number. You're right. I just put it there to show the consistency that I am, in fact, dividing both sides by 4.
Okay.
But yeah, it doesn't change your answer. Okay. So we get x minus 2 squared equals 1. Square root of both sides. So now I have x minus 2 equals plus or minus 1. We're going to add 2 to both sides. So x equals 2 plus or minus 1. So that means I have 2 possible solutions. X equals either 3 or 1. Okay, the last example up here, I want you guys to try it on your own. I will work through it on the board. If you finish early, you can start on the homework. Homework is like 15, 16 questions or something like that. Check your answers with this and then just ask if you have questions.